Hi, good afternoon. In today's lecture, we are going to look new module on mixing, placing, and compaction of concrete. So far, we have looked at properties of ingredient that we use, and then how to proportionate those ingredients to get required or particular grade of concrete. Fine. So now we know how to proportionate the concrete. So having that, the next procedure is how to mix and place the concrete for particular applications. Fine. Outline of this module has these four categories. First, we will be discussing about, or we'll look in detail about batching of concrete. So batching, as the name indicates, how we batch the materials or the ingredients for the concrete preparation, and how do we mix those ingredients together, and placing of those ingredients and compacting those ingredients to obtain a good quality of concrete. So all these steps are essential to obtain good quality of concrete without compromising any properties. So in general, in production of concrete, that involves these process. First, so once you know your mix proportions, or once you know how much you are going to add, how much of cement you are going to add, how much of cementatious material that you are going to add, how much of aggregates or water that you are going to add. So knowing that, you are going to batch those materials so that it will be easy, or you know how much has to be added accurately to the matrix. So for that, the first essential step is batching your material. So in batching, you're basically like preparing in cooking, like you prepare the ingredients, how much certain things has to be added. Similar way, you are going to prepare your ingredients for the concrete preparation. So once you know, or after batching, so those batched ingredients will be sent into a mixer. So where you mix your ingredients, and then once your concrete is ready, so while mixing, so you will have your concrete mix. So once the concrete mix is ready, so the concrete mix has to be transported to the place where it has to be placed. So the transportation part has to be considered, and then so here comes the duration. So if you are mixing inside, then it will be different. If you are mixing your concrete in a plant, then you have to consider the transportation duration. So those factors affects the performance of concrete before placing, right? And then placing concrete. So how do you place the concrete? So either you are going to, like in the mixed proportionate, you are familiar with the type of placement of concrete. So either it can be pumpable concrete or it can be chewed concrete. So where you have some arrangement manually. And then once you place your concrete, you have to compact your concrete by vibrations. So compaction basically ensures that the concrete has good dense structure. So if you are pouring if you're pouring the concrete layer by layer, or if you're just pouring concrete, sometimes less amount of concrete may occupy a huge volume. So by compacting it, you are densifying the structure so that you can pour more things, and this way you reduce the pores in the concrete structures, and also if there are any entrapped air, you can remove those entrapped air by compacting it, because there are certain limits for allowing entrapped air in concrete. There are certain limits for having pores in concrete. If your structure is too porous, then your concrete will not be sensitive or resistant to durability factors, right? So if there are lots of pores and voids present in the concrete, then it will provide way for other foreign elements to enter into the concrete. So to avoid that, you should have a good compacted structured concrete. So for that, compaction plays a major role. So once compaction is done, then your concrete, you are going to allow your concrete to gain its strength, and during the process, curing plays an essential role, because when you are allowing your concrete to gain its strength, it is going to get exposed to the atmosphere conditions. So depending on the temperature, your there will be changes in the concrete. So if the temperature is too hot, then moisture will be lost from the concrete structures. Because of the moisture movement, if there are restrictions, then it will induce shrinkage issues and shrinkage stresses. So if you are providing curing adequately, then that will delay such shrinkage issues. Especially, of course, there will be evaporation of water, but that water will not be from the concrete, but that water is the water will be evaporated from the curing water, so not from the concrete structure. So in that case, that evaporation will not cause any harm to your concrete. So to ensure that evaporation of water or to delay the shrinkage issues in the early stage, curing plays a major role. So after all, after achieving all these things, you have your sound concrete. So now this is the essential step that we look. First, the patching of concrete. So as I already mentioned, the patching means you're going to segregate your ingredients, how much to be added for preparing concrete. So for example, if you are going to add 400, if from based on your mixed proportion, if you know that your concrete, for example, if one second, yeah, if the cement content is about 420 kg per meter cube, then you will be calculating the amount of cement required for your specimen or for the structural element, how much ever you are going to add. So basically, you will be calculating the volume of that particular element, or if you are going to do this batch by batch, then you will calculate the volume, or if there are the structure that you are going to place, you are going to calculate the volume of the structure. So if you know the volume of that particular element, you will be multiplying that volume, and you get your cement content, how much cement has to be added in terms of kilograms. Similarly, you get the amount of fine aggregates, coarse aggregates, and water for placing concrete that particular element of the application. Fine. So the process of measuring specified quantities of cement, aggregates, water, and admixtures is what we call as batching of aggregates. So this batching can be done using volumetric batching or weigh batching. Volumetric batching is a crude way of batching your material. So this was a very old practice where you just so in batch your material based on the container. So one container of this will be fine with respect to half or two container of cement or the water. So this proportion is based on the container, and again this varies person to person, because some may compact or some may have more accumulate more aggregates or more cement in the same volume of container. So this is a very crude way, and you may not achieve reproducible results using volumetric batching, because if you batch the material today using volumetric, and if you batch the material tomorrow using the same volumetric container, then you may end up having different quantities of material depending on how you place it, how you compact it, and again the size and shape of the aggregates will also plays a huge role in this volumetric batching. So now we have very sophisticated techniques where we use weight batching. So this is more reproducible way. So you are going to weigh the weight, so you know exactly how much has to be added to the particular mix. So you can reproduce your concrete, and you can avoid variations in status using weight batching, and it's kind of more economical also, because you are going to produce more uniform concrete. So here, this is a very crude way of concrete preparation, a batch preparation when you use this volumetric batching. And here, using well batching, you can avoid such practice, and it will help you to produce more uniform concrete matrix. So once you batch the materials, it is also important to how to store those materials, right? So if you just batch the material, and if you leave your materials outside or without proper storage, then like if it is water, there could be some water loss due to evaporation. If there are aggregates, and depending on the atmospheric conditions, your aggregates may for batching, you do this water correction for the aggregates, right? So the condition of aggregates may change if it is just exposed to the atmospheric conditions. So the obviously it will not be necessary conditions. If your aggregate is dry, maybe it may get too dry, but the water correction you might have done for the aggregate will change then. And if your aggregate is wet and the moisture content may get reduced, but before that you might have done a water correction. So these things will affect the fresh properties of aggregate while mixing the concrete. So fresh properties of concrete while mixing it. So cash should be given for proper storage. So aggregate bins will be used for storing aggregates. There are certain places where you can see dust storms. In that case, if you leave the aggregates outside, just like that, so dust may get accumulate on the surface of aggregates, so that may induce more fineness in your concrete. So if there are more fineness, then that will lead to high water demand, and that will affect the workability when you mix. Then you end up just adding more water during mixing. So that is not a good practice of doing it, doing a good concrete preparation. So to avoid all such issues, it is better to store aggregates in a proper storing container. So typically, it is aggregate bins are used for storing aggregates. And for cement and cementitious material, of course, the similar way, when you left your cement outside, there could be possibilities for forming lumps, and the effectiveness of binding may get reduced, so it is always better to store the cement in a proper way. Silos are used to store the cements and cementitious materials, especially if you do batching for large infrastructure project. And this kind of batching you can see in ready-mix concrete plant or precast yard industry. You may not see such things when you do concreting on site. So there maybe your materials will be exposed, but care should be taken care such that the variation is not significant. So when you talk about batching plant, so there are different components of batching plants which help us to batch and store the materials. So as I told, aggregates will be stored in aggregate bins. Again, different types of bins will be used for different types of aggregates that we have. So we have fine aggregates, we have coarse aggregates, different bins will be used. And then from one place to another place, it will be carried by feeding mechanisms such as scrapper or conveyors or hoist, etc. So to transfer aggregates to scales or balances. This is to measure the aggregates. So from the aggregate bins, so the aggregates will be transferred to the place where the aggregates will be measured. So there are some balance and measuring systems that will help us to get the accurate amount of aggregates to be added, either aggregates or cement, whatever it is. So there are mechanical leverage systems and load cells. These will help you to get the amount weight of the ingredients, and electrical and micro and moisture gauge is also available. This basically gives you the moisture content of aggregates so that you can do the moisture corrections in your mix proportioning, because you might have arrived your mix proportioning, not you arrived your mix proportioning based on SSD conditions. So knowing moisture content is very crucial. So you will get the moisture content using this micro gauge. You just place the aggregates in the microwave oven, and then after 3 minutes you can take out the aggregates and measure the weight, and the difference between the before and after high temperature exposure will give you the moisture lost. So that is basically your moisture content to do for moisture corrections. And then your cement will be stored in silos, and conveyors or some screw bucket conveyors will be placed there to take the cement from that place to the mixing place. So basically to the mixer where you mix your ingredients. And then we might there should be a tank or the container to store water, and dispensers for chemical admixtures. So when you look at batching plants, these are the important components that you should have for weighing and storing your materials. So this is an example of batching plant. So you can see there are silos kept for storing cement material, and there are silos that kept for storing cementitious materials. And here you can see bins to store the aggregates. So different types of aggregates, coarse aggregates and fine aggregates. And nowadays we have more sophisticated tools, especially for large infrastructure projects or in a precast unit. So there are some walls where these materials are stored, and those are computer controlled, and using the control room you can actually feed the values how much ingredients has to come out from the particular storage unit. So based on that, so you are there are some gates to open. So here you can see in silos there will be some wall to open so that you can get your material out of your silos. And similar way in the bins there should be some gates. So when the gate opens, your material comes out. So all these things are computerized now. So you can feed your values for particular batching so that the exact amount of material will be conveyed or that will be sent to the mixers. So this kind of helps you to reduces the error due to manual weighing, or when the person transports material from batching to mixers units. So this kind of automations helps you to obtain more uniform, reducing other kind of errors due to manual measurements. So batching is the thing that controls the variation in your concrete mix. So IS look in detail about those specifications. So section 2 talks in detail about section 2 talks in detail about the concrete material itself. In that you can see a subsection which talks about the importance of batching and mixing and tracing. So that gives you tolerance, and this is from IS standard specifications. You can see how much variations or tolerances in variation is allowed for different types of material. If you choose your cement material, then while batching, you can see plus or minus 1% variation is allowed. If there are plus or minus 5% variation, then that will significantly affect your mix design, so that the water cement ratio will be significantly affected. So in order to maintain a uniform mix, you should ensure your batching is uniform. So sometimes if you are not able to control your variation, then these tolerances are allowable. So your variation should not exceed the specified tolerance values given in IS codes. So uniform concrete will be obtained only if there are variation is less. So for that, you should ensure your batching is proper to ensure better quality of concrete. Okay. So now, once batching is done, you will be mixing all the ingredients to get the placeable of workable concrete, right? So mixing is done using rotation or stirring the ingredients together. So basically this mixing ensures it coats all the surfaces of basically the cement, the fine particles that binds the larger aggregates. So to coat the surface of the aggregates with cement paste and blend all the ingredients to get a uniform mass. So to obtain a uniformity, your mix should not be disturbed during this discharging process. So here during mixing we have three stages. One is loading stage where you place all your ingredients together, and then mixing stage where you mix your ingredients for a particular duration, and then you discharge your material once the concrete is ready. So the concrete will be unloaded, basically unload from the mix. So during this process, during this mixing and during this unloading process, your mixture should not be disturbed to ensure uniformity, because while unloading it, if you disturb your concrete mix, if there are impact, or if the concrete has fell down, then there may be possibility for segregations. So to avoid such segregations, you should for your mix should not be disturbed. There are two ways of mixing your concrete. One is using hand mixing. Another, here as shown in this figure, you just pour your ingredients and just mix it using some shovel or other instruments. But this is no more in practice, and we don't recommend such hand mixing because you will not get uniform mix by hand mixing, because efficiency will vary with person to person, and again that will lead to significant scattering in your result. Basically, the standard deviation that you use for your concrete mix design will have significant impact if you are not preparing your concrete, if you're not using adequate measures. So, because if there are such disturbance during this mix designs will lead to significant variation in your result. Another way of mixing is batch mixing or machine mixing. So in which it involves certain, it kind of a continuous mixing, and it is fully automated, especially in case of continuous mixing. And batch mixing, in that case, you have certain mechanism to mix your concrete so that the efficiency will be maintained uniform throughout your mixing, and even for other batches of mixing also for particular concreting. So this will help you to obtain more uniform concrete mix. So for that purpose, we have two types of concrete mixers. One is batch mixers, another one is continuous mixers. Batch mixers, in the sense, like you will be casting, you will be concreting, preparing your concrete batch by batch. So you will you will prepare concrete for particular volume of structural element, and then after a day or after a couple of days, you will be doing another batch to fill the concrete. So this is the case when you do a small project and where the concreting is not continuous or regular. So in such cases, batch mixers or different. So if you have a very large infrastructure project where the concrete has to be done continuously, and large infrastructure project and also precast industry, so where they produce concrete elements continuously. So in that case, you have continuous mixtures where the ingredients will be sent continuously from the batching plants to the mixtures, so that the productivity also be higher and the efficiency will be higher, so you can produce more concrete elements. In the first case, we have four types of mixtures. So so depending on how the mixture is rotated and the shape of mixture, it is classified as tilting drum mixer and non-tilting drum mixers and fan type mixers and dual drum mixers. So as the name indicates, the first type, the tilting drum mixers, the mixture is rotated and then it will be tilted to discharge the or unload the materials. So the drum, it will have two openings. So one opening will be here at this end, so where you can load your ingredients and then you can mix. So here you can see the lever arm. So sometimes manually you have to rotate this, or sometimes it will be automated so that you can fix your number of rotations and the duration of rotations, those things. So once your concrete is mixed, then you can unload the concrete via this opening. In this case, most often the drums will be in conical or bowl shaped with internal veins. So you can see some your mixture will have some internal blades which will help you to mix well all the ingredients that is placed inside the mixer. So while discharging it, so this lever arm will be used, so that you can tilt your drum by rotating this, and gas should be given to avoid any segregation. So if the discharge is rapid, then segregation may occur, especially for the mixers which has low workability and which contains large size of aggregates. So in such cases, you should discharge your concrete very gradually to avoid any segregations. And another type of mixture is non-tilting drum mixtures. So here This has the axis of rotating mixtures horizontal to mixer. The axis of the mixer will always be horizontal, and the discharge takes place by manually by arranging inserting some jute into the drum, so where you can unload your material, or else there will be some mechanism when you reverse the direction of drum, the material will be discharged, or the concrete will be discharged. The slow rate of discharge, some segregation may occur, part of post segregate being discharged late. So again here the rotation, the speed of rotations or the rate of discharge will affect the segregation. So there the rapid discharge, so the gradually you have to tilt your drum mixtures. So here gradually you have to discharge. The rate of rotation should be way that it will not cause any segregation. This type of mixture is charged by means of loading skip. So where you have larger tilting drum mixers, there also by mixing it you can use these drum mixtures for effective discharging. And you should give importance to the discharge from like where to be transferred from skip into the mixer every time. So the time for this transfer should be as minimum as possible. And another type of mixture is pan type mixture. So here you will be mixing your concrete in this type of pan, and this is based on 4 shafts and mixer. And here it's very different from the drum mixtures where which lies the free fall of concrete inside the drum. So when you rotate, the concrete will be flowed inside the drum, so which will ensure your mixing. But here in this case, you have internal blade, like here it's kind of star pedal type of arrangements will be placed inside, so which helps you to mix the ingredients. So typically it contains a circular pan rotating about its axis with 1 or 2 star of pedals rotating about vertical axis. So where once your material is poured, this top portion will be closed, and then this is automated. So once you turn on your mixer, so this portion will start moving around inside the pan. So when this moves, that ensures a good mixing, so that helps all the ingredients to mix well. And depending on the type of aggregates, or depending on the type of mix that is there, you can adjust the position of the star pedals, so that if you want to ensure a mix well in one particular locations, that can be done when by moving these pedal mixtures to that particular locations. And also there are arrangements here, so that will ensure that particular locations which has to be mixed well. So you can move all these things around inside your pan mixer. So the height of pedals can be adjusted to prevent the formation of coating or mortar again. So once you mix when you mix your aggregates, when you mix your ingredients, it is important to ensure a proper coating, and sometimes some of the coating or the paste materials may get stick to the walls of this mixer or at the bottom of this mixers. So to remove that, and to make sure there is no such fine particles adhere to the surface of the matrix mixture. So there are arrangements. So this portion will move around, so that it scraps the material that is there on the walls of the mixer. And by adjusting this height of pedals, that prevents any fine materials that is pasted to the bottom of this mixture. Right? By adjusting this, you can ensure that your material is not wasted by sticking to the mixture. So you have all your materials for the mixing of concrete. So effective with stiff and cohesive mixes, and so often used for precast concrete, and this is more suitable when you have less quantity of mixtures and especially in the laboratory conditions. You can see such pan mixers in our laboratory for concrete preparations. And the fourth type of mixture is dual drum mixtures. So here you have two drums in series, and typically this is used in highway constructions where you need to concreting for a long. So you have two drums in series. So concrete will be mixed in one drum. So concreting will be done in stage by stage. First you will be adding aggregates, and then you do a dry mix. So there will be some dry mix, and then you add some amount of water, maybe 25% of water, and you mix it. And this water kind of coats all the aggregate surfaces, and then only you will add a cement and the remaining water. And if you have any SP to be added, you will add SP. Fine. So once all this is done, this may take some a few minutes, and then your actual concreting will take some few minutes. So to enhance the productivity, when you use these drums, so all this initial preparation will be done in one set of drum, and then once this mixing is done, then further this material will be sent to the next drum where the concreting will be taken care. So in the meanwhile, the next batch of material will be ready in the previous drums where you do this initial preparation. So by doing this, you can achieve more yield of concrete. So in a short time, you can get more concreting for that application. So meanwhile, the first drum is recharged so that initial mixing takes place without intermixing of the batches. So this will be effective when you need to do concreting for large structures, so especially in the highway constructions. So for roading or for bridging, so you have to do concreting for long distances. So in such cases, when you use this double drum for the same duration, your concreting can be doubled because the mixing will be done. So initial preparation will be done in one drums. Once that is ready, the concrete the ingredients will be sent to the concrete mixing, so that the initial drum will be ready for the next batch of concreting. So where initial preparation will be done for the second batches. Once this first batch concreting is done, then the second batch concreting will be immediately sent to the second drum. So it kind of avoids any, it kind of prevents delay in the concrete mixing, and the concreting will be done continuously. So that for a given duration, you can enhance the yield of concrete. And then the another type of concrete mixtures, especially for large infrastructure, you have continuous concrete mixtures where the loading and mixing will be continuous until you stop your concreting process. So from the batching unit, if all the ingredients are computerized, so you know your ingredients will be sent in a certain batch. So the required mass of ingredients will be sent to the mixtures, and then the mixing will be done continuously. And here the feeding mechanism will be by screw feeders, or else some places it will be like a conveyor belt, so which supplies the ingredients continuously to the mixtures. And once the concrete mix is ready, the discharging will also be done continuous. So here you can see a belt conveyor is used for discharging the materials from the concreting unit. So now all this process, the batching and mixing we do for ensuring the good quality of concrete, especially to achieve uniformity. So when we have to achieve uniformity, we have to check certain parameters or certain performance of concrete so that you know your concrete has good uniformity. So ASTM has specified such specifications when you do two samples or when you test the samples from different batches of concrete, then the variation should not be, a variation should be within this limit. So when you do the batch to test, when you test the samples from two different batches, the density of concrete between those two batches should not exceed 16 kg per meter cube. So the variation between those two batches should not be more than the specified value. Similar way, you have to check the air content and slump of the slump of concrete, and this is during before concreting itself. You have to check the aggregate size for the particular batch and density of air free motor and compressive strength. But in general, in practice, we do check density of concrete and the air content, slump, and compressive strength of concrete, and see the variations all within the limit between the batches. If the variation is more, then you have to identify why the variation is significant and you have to fix that issue. Else, you have to work on your mix proportioning detail so that you can concrete design. So again, there are to obtain uniformity of mixing. So another important thing is mixing time. I just note down here so that we include this in the slide. Depending on the capacity of the mixer, so there is a limit for mixing time. When the mixing time increases, it basically distributes the ingredients to proper hydration, and that ensures the increase in strength. But too much mixing will not be good because that may grind the over grind the aggregates, may lead to more fine particles in the concrete, and that will affect the fresh properties of concrete. So mixing time is specified for certain capacity of mixtures. So if your mixture capacity is about 0.8 meter cube, then your mixing time should be 1 minute. It should not be more. Similar way, if the capacity of the mixer increases, for example, if your mixer capacity is 1.5 meter cube, then the mixing time will be 1 minute and 20 seconds something. So if your capacity is about 2.3 meter cube, then your mixing time will be 1.5 minutes. So if your capacity is about 3.8, then your mixing time will be about 2 minutes. So as the capacity increases, your mixing time will increase. But for a given capacity of mixer, your mixing time should not increase more than 1 minute, because over grinding of aggregates will affect the properties of concrete. For example, if I'm just drawing the plot here, so if you have a plot for the mixing time and then strength and variation of your concrete. So over the time, if your mixing time increases, because initially there will not be any strength before mixing, because you just put all your ingredients in the mixer. So once you start mixing, that hydration process will start occur, and the distribution of ingredients ensure a good uniformity, and your strength will increase over the time. But after the particular duration, there will be significant increase in the strength, so it will become stable. Okay, that's where we stop our mixing. But this kind of ensures, so this is strength, so strength increases over the time. So when you ensure a good uniformity, then your variation will be less, because before mixing, the ingredients will be just placed, and once you start mixing slightly, the variation will get reduced, right? So the variation will get reduced as the mixing time increases, but over the duration, So once the optimum duration is reached, and again if you are overgrading, then that may increase the variation also, because overgrading may lead to more fine particles in the concrete, and if fineness increases, then the water demand required will also vary. So for a given mixed proportion, so that will affect the fresh properties of concrete. So that's why the variation increases if the duration is more than optimum. So you have to ensure, so by practice you get to know for a particular capacity of concrete and particular batch of concrete, sorry, for particular capacity of mixer and for particular batch of concrete, you know how much should be the optimum time, and you should maintain the time for all the batches to ensure uniformity and less variation in the between the concrete batches. Fine. So I'll stop here, and in the next class we will discuss about how to place the concrete and the compacting concrete. So with that, this module will be over, and we'll be focusing on hardened and fresh properties of concrete in the next module. And if possible, please go through the specifications given in IS 456 for mixing, what are the precautions that we have to do, and what are the acceptance criteria for mixing and transporting material and placing the concrete. So just go through those things. So since there's IS specifications, it is important to know what is specified in the code for your references, right? So if anyone has tried the word code problem that I had given in the previous class for concrete mix design, if yes, you ping me separately, and just we can have discuss. Maybe I will give some bonus marks if you worked out those samples, because I have not given a assignment for compulsory marks. Fine, I'll stop here. We will continue from the next class. If you have any doubts or if you want to have any clarification, we can